delay. A very good morning to all of you. Today's class, the topic is applications of electrolysis. Electrolysis we have already done. We will be doing applications of electrolysis. Electrolysis finds several applications in industry, especially in industry. One of them I told you earlier. I don't know if you remember. Nowadays we all need a lot of oxygen in the hospitals. Oxygen is required in the hospitals, and that oxygen comes from electrolysis of water. Water is electrolyzed not for oxygen, generally it is electrolyzed for hydrogen. Hydrogen is a very essential element we require because all oils that you get today, they are hydrogenated oils. Yes, oils like Saffrola and various refined oils you get in the market, they are all hydrogenated oils. So that hydrogen is required. And to get hydrogen, water is electrolyzed. Electrolysis is what we already learned through Hoffman's voltmeter. Hoffman's voltmeter 3 into 1, we have done already. So in the industry, water is electrolyzed to get hydrogen. Oxygen becomes a byproduct. BY, we are only using byproduct. But it's a very important byproduct because they find use in hospitals. Today, so applications of electrolysis. One is to get industrial chemicals like hydrogen, oxygen. Chlorine also in the industrial chemical is very much required. Chlorine. Chlorine is obtained by the electrolysis of brine. By the electrolysis of brine, you get chlorine. 20% brine. Brine is sodium chloride, brine. So by the electrolysis of brine, 20%, we get chlorine. And chlorine is very essential, industrially a very important chemical, gas, chlorine. Another important chemical we get from electrolysis is sodium hydroxide itself, which we call caustic soda. Caustic soda, or NaOH, sodium hydroxide, that is also obtained by the electrolysis of brine. So these chemicals we get industrially by electrolysis. This is one of the applications of electrolysis, the manufacture of industrial chemicals. Manufacture of industrial chemicals, that is one of the applications. Manufacture of industrial chemicals. Manufacture of industrial chemicals. This is one very important issue. Other applications involved, number one is electrometallurgy. Second, electrometallurgy. Electrometallurgy. Electrometallurgy, that is extraction of metals. Several metals are extracted through electrolysis, especially sodium. Sodium is a very active metal. It is obtained only through electrolysis. Electrolysis. Sodium, calcium, magnesium, such metals, they are obtained through electrometallurgy. Electrometallurgy. The third one is refining of metals. Refining of metals. Some metals, when we prepare those metals, extract those metals, they are contaminated. They contain other things also. It's not very pure metal. From the coarse metal to get a pure metal, we use refine. That's called refining. From coarse metal, getting pure metal is called refining. For refining metals also, it's an application of electrolysis. And finally, and finally, uh, electroplating. That's also a very important one. Electroplating. Electroplating. By electroplating, we decorate metals. You must have seen nowadays very popular 1 gram gold ornaments. Those 1 gram gold ornaments are all obtained by electroplating. Electroplating. Pure gold is plated on the other metal. Right? It becomes 1 gram gold. They are costly. They are also costly, and they decorate the metal. Apart from that, they add beauty to the metal. That's known as electroplating. And electroplating is very useful very often. We have to electroplate certain things for using. For using, you have to electroplate. Now, you have got, say, a brass lamp. A brass lamp you have got. You must have seen the lamps used in southern India. Here only, especially in Kerala and other places, a lamp of this kind is used. Have you seen this? This type of lamp. This is a lamp. This is a wick, it can burn. For if you want to make this lamp more beautiful, suppose it is made of iron or brass, you can plate it with silver. You can plate it with silver, it will be very beautiful to see. Right? That's not electroplating. Some people plate spoons, etc. with silver. That gives a rich look. A silver spoon is normally used, born with a silver spoon in mouth, is often said, which shows richness. Silver spoon. So ordinary brass or copper spoons can be changed to silver spoon, and if you want the gold spoons also. That way, it becomes the looks become expensive. The expensive looks for that electroplating is very commonly given. So these are the four applications of electrolysis. Four applications: manufacture of chemicals, industrial chemicals, electrometallurgy, refining of metals, and electroplating. Four of them. Got it? Okay. Now we'll take up electroplating first. First we'll take up electroplating. 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 That's one of the uses. We'll take it up first. What is electroplating? It's a process in which a thin film of a costly metal can be deposited on a base metal. It's a process by which a thin film, thin film of a costly metal can be deposited on a baser metal. We say base metal. Base metal means cheap metal. So a costly metal can be deposited on a baser metal through electrolysis. That's known as electroplating. So electroplating is a process in which a baser metal can be made to look more attractive and beautiful by getting a costly metal deposited on it. Get it? Yes. Why do we do that? We do that number one for first we do it for decoration purposes. One reason why do we do it is for decoration purposes. Okay, and second, and there's another reason also. Sometimes we do it not only for decoration, but for stopping the basic metal from getting rusted. To stop rusting. To stop rusting. Basic metals can get rusted. To remove once it is coated with a better metal, it will not get rusted. Silver doesn't get rusted, gold doesn't get rusted, only iron gets rusted. So to stop iron from getting rusted, I either give a coating of silver or it can be a coating of chromium or nickel. Nickel plated things you must have seen, nickel and chromium. They are also plated on iron tools and all that. So these are the two main reasons why we get objects plated, right? One, decoration purpose. Second, to protect from rusting or corrosion. Rusting or corrosion. To protect from rusting or corrosion. By gold plating, expensive look can be produced. By gold plating, we give it an expensive look, an article made in gold. Yeah. Next is conditions for plating. Conditions for plating. Electroplating. I said plating is electroplating. Conditions for electroplating. What are the conditions for electroplating? To be satisfied. You will So the conditions should be satisfied for electroplating. Number one, we know it already. The article to be plated. We plate it on some article. That article should be used as a particular electrode in electrolysis. What's that article? The article to be used. Which is that article? The article to be plated should be used as a particular electrode. There are two electrodes in electrolysis. What are the two electrodes? Anode and cathode. The article to be plated should be anode or cathode. Article to be plated. A spoon is to be plated. Spoon should be cathode or anode? Cathode. Spoon should be cathode. Cathode. Why? An ion should go there. Ion should go there. Receive an electron, change into an atom, get deposited. You understand? Say copper ion. Copper ion moves to the cathode, suppose. Copper ion is Cu2 plus. It needs two electrons, it gets to the cathode. Cathode is connected to the negative of the battery. So it has got electrons there. Takes two electrons, changes into Cu. Cu2 plus two electrons will change into Cu and get deposited there. So the article to be plated should be used as the cathode. That's number one. Number one, article to be plated. Article to be plated. To be plated. PLATED, not PLAITED. You know what is PLAITED? You know. Yes. Article to be plated. Article to be plated. To be used as cathode in electrolysis. Article to be plated to be used as cathode in electrolysis. Second, the metal with which the article is to be plated article is to be plated. The metal with which is the article is to be plated should be the this electrode. Anode. It should be anode. That should be the anode. Suppose you want to plate a gold bar or a gold plate should be the anode. If you want to plate with copper bar should be. They are active. I told you they are called active anodes. When you use an active anode, the advantage is the active anode will not allow any other ion to get released again. Because it is more active than the OH ion, NO3 ion, SO4 ion. They are the anions. No? OH ion, SO4 ion, NO3 ion, chloride ion, bromide ion, iodide ion. These are the anions, right? But gold, silver, etc. come much lower in the electrochemical series than those. So gold, silver, etc. will be affected first. Not those OH should not go and release an electron and change into OH particle, give oxygen electron happen. Because the electrode used is a very active electrode. We call it an active electrode. It takes up electrons very fast. Sodium will take up electron with great difficulty because sodium is electropositive. It wants to change its electron. So if it is a sodium atom, it wants to change into sodium ion. Very active. Very active. So suppose you give an electron to sodium ion, it's very difficult to change into sodium. That can happen only at the cathode. Never else. So the metal with which the article is plated should be there. Metal. Article related should be there. Then third, the electrolytic cell should be made of what? The electrolytic cell should be made of what? It should be something, it should be made of something that does not react with the electrolytes. It should not react with the electrolytes. The electrolysis should not be gathered. Usually the electrolytic cell is usually made of, either it's made of plastic, or it can be made of ceramic, plastic, ceramic or glass. These do not react with other reactors. That's why glass containers are used, because they do not react with the other substances. So plastic, ceramic, glass, container should be used. Container should be used as an electrolytic cell. Should be used as an electrolytic cell. Plastic, ceramic, and glass container should be used as an electrolytic cell. Got it? Now, fourth one, anyone? What is the fourth requirement? Fourth requirement in electrolysis?
Acidified.
The electrolyte. Next requirement is electrolyte. We should select a suitable electrolyte. A suitable electrolyte should be chosen. So a suitable electrolyte must be chosen. These are the four requirements for electrolysis. Other small requirements are there. We need a battery which gives current. We need a key to be pressed to start the battery functioning. Sometimes they also put in the circuit an instrument to measure the current. Have you done electricity in physics? No. So an instrument that measures current is called ammeter. It's called ammeter. That is also put in the circuit. Electric circuit, we also put in an ammeter to measure the current, how many amperes current to measure. Then you need a switch. By pressing this mechanism can be started. We need a battery. Negative of the battery will be connected to which electrode? Negative of the battery will be connected to which electrode? Negative of the battery to be connected to cathode. Negative of the battery will be, battery is usually shown like this. This line is positive, this negative. This is positive, this is a positive. This should be connected to the cathode. This should be connected to cathode. Negative. Or the plate which is connected to the negative is a cathode. And this should be connected to the anode. This should be the anode. If it's a spoon or something, the spoon will be there. Now what they do is in between you keep a switch. This is a switch. Pressing this, electricity will flow. This is also called a key. This is also called a key. And also on the way here, we keep an ammeter. This is called an ammeter. Ammeter. The current can be measured. That's the arrangement. We will have a proper diagram drawn. Okay. So these are the requirements for electrolysis. For electrolysis, always we use a low current. A low current used for a long time produces better plating. Better plating is obtained by a low current used for a long time. A low current used for a long time. If you use a high current, the plating will not be good. Plating will be spongy. It will come out afterwards. Right? So these are the requirements for electrolysis. Now we will do how to do electroplating. Actual there's possibility of showing experimentally here. Can be actually seen experimentally. With the studio, so you can see that also. But you should know how electrolysis is done. We go to the first one. First requirement. First requirement is an electrolytic cell. First requirement is an electrolytic cell. This is an electrolytic cell. This is made of, either it is made of glass or ceramic or ceramic is a stainless porcelain. Ceramic container. The electrolyte is taken in this container. Here is the electrolyte. Now there is a cathode. This will be a cathode here and anode here. Anode is made of a plate of the metal which should be plated. A plate of the metal, that metal is going to be plated on the other one. That's anode. And the cathode will be, say if it is a spoon, suppose we want to plate a spoon. That spoon is kept dipping in the electrolyte. This is the spoon. The only way I can show the spoon. So that is the spoon to be like electroplated. This is electrolyte. The solution is electrolyte, and this is the spoon, which is the cathode. Cathode is a spoon to be electroplated. You get it? The spoon is connected to This is connected to a battery. There is a battery. It's a battery. Anodes. This is the anode. Anode. So anode is connected to the positive of the battery. You got it? Spool should be connected to the negative of the battery through a switch and an ammeter on its sleeve. This is ammeter. The spool is connected to the ammeter, the key, and the negative of the battery. Got it? Cathode is a spool. This is the ammeter. This is the key. And this is the battery. Actually, it is called a battery only if there are two or more cells. It is called a battery only if there are two or more cells. I am showing you two cells. There are two cells now, you can see. Two cells. Only when there are two or more cells, it becomes a battery. So this is the battery. But the negative is connected to the cathode, positive is connected to the anode. If the key is pressed, electrons will flow through the electrolytes. The result will be, what is the result? Now, first of all, now supposing you want to plate a spoon, you want to plate a, say, copper spoon. A copper spoon you want to plate with silver. Supposing you want to plate a copper spoon with silver, then this anode must be a silver plate. Anode must be a silver plate. Silver plate. Plate can be thin, can be thick. Silver plate. And the cathode must be the, what is cathode? It is the spoon that has to be plated. Hope you get it? Electrolytic cell made of ceramic or glass. It contains a electrolyte. What is the electrolyte used for this purpose? You want silver to be deposited on a copper spoon or a brass spoon. Say it's a brass spoon. Brass spoon. So on a brass spoon, we are getting silver deposited. The solution used for this purpose usually will be a salt or silver. Solution to be used, electrolyte to be used should be a salt or silver. Whichever metal is to be deposited, the solution should be a salt of, it contains a salt of that metal. That particular metal. So the metal here is anode. This is an anode, and the anode is silver plate. And the copper spoon or the brass spoon, which is to be plated by silver, that is the cathode. When the key is pressed, suppose the key is pressed, electricity will be allowed to pass through the solution. The electrolyte used, in this particular case, what is the electrolyte used? It should be a salt of silver. Can you name a salt of silver? Silver? Chloride. Silver chloride is insoluble in water. It should be a soluble salt. Silver nitrate, all nitrates are soluble. Any nitrate in the world is soluble. Okay? So, silver nitrate is not soluble. So, nitrate can be used. But silver nitrate is not very good for this purpose, I will tell you later. The deposit of silver that you get using silver nitrate, it will not be very fast. It is not fast, it is big, filmy, which will come out easily. So the solution we are using a mixture of sodium cyanide, NaCN plus silver cyanide, AgCN. AgCN plus NaCN mixture. This is a cyanide mixture, please understand. Cyanide, sodium cyanide, silver cyanide. Cyanide is extremely poisonous. Cyanide is extremely poisonous. A drop of sodium cyanide will kill a person. If you just have a drop of silver cyanide on our tongue, within within 1 or 2 seconds you will die. So poisonous. We don't know what's the taste of silver cyanide. Someone wanted to know this taste, so he tasted a little, and probably he wrote S by the day he died. Yes. His friend also wanted to say, so he tried again, he wrote O by the time he died. It is sour widow, you don't know. Okay. What I say is silver cyanide is poison. It's a treacherous poison. Treacherous poison, fatal. Fatal. So this is not kept in the laboratories. This is not kept in the laboratories usually. Usually if it is kept, it's kept in a double locker almirah, key always with a custodian. Right? You tie it with a thread and keep it outdoors. Because it's a treacherous poison, both silver cyanide as well as sodium. The mixture is to be used, but in the industry it has to be used. When it is mixed, you get something called NaAgCN twice. When these were mixed, they react and produce something NaAgCN twice, which is known as sodium argentocyanide. Sodium argentocyanide. Sodium argentocyanide. NaAgCN words. Sodium, that is an electrolyte used for this purpose. This is the electrolyte used for this purpose. So I told you what's the electrolyte, what's the electrode, what's the cathode, electrode, cathode, also what cell is used. Cell used ceramic or glass. Electrolyte is sodium argentocyanide prepared by mixing NaCN with AgCN. We combine and produce NaGCN. NaAgCN. And then the spoon to be plated, that is used as the cathode. The metal which should be plated on it, that is used as the anode. Here in this case it is silver. Silver is a plate of silver is used for that. Electricity, a low current is passed through it. When what reactions take place, you can easily understand. What are the reactions take place when electricity passes through it? NaAgCN twice will first split up into Na plus Ag plus Cn 2 minus. Hope you understand this. NaAgCN twice is Na ion, Ag ion, and cyanide ion. Cyanide ion is 2 valency 2. Ag ion, cyanide ion, and silver ion. Now this dissolved in water. This is dissolved in water, otherwise you got two solid substances. So dissolved in water, so water is also there. Water will give, this is the reversible arrow. Water will give H plus and OH minus. You get it? H plus and OH minus water. NaAgCN twice means Na plus Ag plus Cn. When electricity is passed through it, what will go towards cathode? Think about it. Out of these, what are the ions available? What are the positive ions available? Positive ions available, which are the ones?
Sodium,
One is Na,
Ag,
one is Ag,
H,
and then
H.
H plus, hydrogen. Anything else? These are the only positive ions. These positive ions will go towards the, they go towards the cathode. Okay? When they go towards the cathode, out of all these three, the lowest in the electrochemical series is
AG.
AG, silver. The lowest silver. So the other two, all the three will compete. All the three will compete to get plated. But AG is the lowest in the series. It succeeds and it gets plated. The other two cannot get plated. They remain in solution. They cannot get plated. Okay? So AG will get plated on this one. AG ions will get plated on this one. Now, what are the negative ions available? Negative ions available are one is negative ions. One is OH minus, it is there. Then CN2 minus. These are the negative ions available in solution. They should go towards the they will go to the anode. The negative ions CN2 minus and OH minus, they go towards the anode. But none of them will be accepted the anode because anode is made of pure silver, is an active metal. It is willing to give out electron. Then why take it from CN twice? Right? The silver itself is willing to go to give electrons. So it will not be taken from CN twice or OH. Instead, silver will change into AG, will change into AG plus and an electron. You know, AG will change into AG plus and electron. Electron will go to the anode. Electron, the circuit has to be completed, so the electron goes to the anode. But AG plus, where it will go? AG plus will go into the solution. AG plus will go into the solution. Alright? AG plus will go into the solution, so the concentration of NaAgCN2 will not change. Whatever Ag is deposited on it, that much Ag will go into the solution. The amount of Ag deposited on the spoon, the same amount will go from this to the solution. The result will be, as electrolysis proceeds, the spoon will get plated. Spoon will get plated by sugar. And what will happen to this plate? It will dwindle in size. The silver plate will dwindle in size. Dwindle. First it is so big, slowly it will become so big, and it is slowly, then it dwindles in size. So after some time you will have to change the silver plate. When the size is nothing will be left, then you will have to change the silver plate. Because silver from here is getting transferred to the spoon. You get it? This is electroplating by silver. Now there are certain precautions to take. Precautions. I told you, number one precaution is a low current used for a longer duration of time will ensure better deposition of silver on the spoon. A low current used for a longer duration of time will ensure better deposition of silver on the spoon. And that too, not only better, it will be very fast deposition. Fast means it will not come out easily. Right? It gets deposited fast. That means it will not come out easily. So, a low current used for a longer period of time ensures better deposition of silver. Number two, second, the spoon to be plated. The spoon to be plated should be cleaned very well before being used. Excuse me. It should be cleaned very well. How is it cleaned? First, it is cleaned in sodium hydroxide solution, NaOH solution. First, to be cleaned in sodium hydroxide solution. Now, sodium hydroxide can remove grease and other things. Then, Again, washed it in hydrochloric acid. First, washed in sodium hydroxide, then in dilute hydrochloric acid. And after that, it is washed in water, then in a soapy solution. In a soapy solution, not soapy solution, a solution of soap which does not contain soap. What is it called? A solution of soap does not contain soap. What is a solution? It's called a detergent. A detergent is soapless soap. Detergents that we use for washing and all, what is Rin or Surf, Tide and all that. They are detergents. They are soapless soaps. They heal out of lather, but they don't contain soap as a best, so it doesn't affect your skin. Detergents don't affect the skin while washing. So if you use soap continuously, well, it can affect your skin. So with a detergent, it is washed again. So first sodium hydroxide, hydrochloric acid, water, and then detergent. Detergent, usually the chemical name of detergent is sodium lauryl sulfate. Lauryl sulfate. This is the name of the detergent, usually sodium lauryl sulfate. So that is used for washing. The spoon should be very clean in that, in detergent solution, and then in water again, and finally in distilled water it will be clean. So all this cleaning process should be done. Sodium hydroxide, hydrochloric acid, and water, then detergent, then water and distilled water. It will be cleaned very well. Okay, and finally, after electrolysis also, the spool is taken out from solution. You should first clean with water, distilled water, and all very you should clean. That's very important. Then otherwise the shine will be polished also. Then only the shine will be. It is what this water it is washed in distilled water and then polished. Right. Okay. Any questions on this? Think about. Find out. Come on, scrape your mind and find out. Any questions? Any questions you are ready to understand? Hmm? You get it now? Thorough? Thorough? Not so. The exam. Is it time up? Hmm? So that is electroplating, which the next class you learn electroplating with nickel, how it is done, and nickel and chromium, how to do electroplate particles. All right, that is for today. Bye.